Welcome everybody to today's webinar, all about heat pumps and new construction. Today is about, here we go, heat pumps for new single-family homes, really geared towards homeowners and realtors. The next webinar on August 16th is also going to be for new homes, new construction, condos, townhomes, regular single-family homes, but it's going to be geared more towards builders and architects. So be sure to sign up for that one for August 16th as well. This slide shows all of the sponsors for our heat pump webinar series that we've been going through. This is our fourth webinar that we've done. So thank you to all of our sponsors. This is the regional area up here in the Upper Rocky Mountain region. Summit County, Eagle County, Garfield County, Pitkin County, the Roaring Fork Valley over there. Loveelectric.org. This is an excellent resource for everything electrify for your home, especially heat pumps. Lots of great information, not only for new construction, but also existing homes on how to upgrade to heat pumps or to implement those heat pumps in new construction. So check out this website. This page is about Holy Cross Energy. This is our local co-op electric provider up here in Eagle County in the Roaring Fork Valley. And they do have rebates for new construction electrification. So if you are doing a heat pump in new construction, just know that there are rebates available from Holy Cross Energy for that and to reach out to them. On the bottom part of this page, these are the requirements to qualify for a heat pump rebate. Energy Smart Colorado is a nonprofit that operates all over Colorado, offering energy efficiency, home energy assessments, rebates, incentives, electrification work, just really a community resource. Energy Efficiency Colorado is housed in local nonprofits in all of these areas. So if you're in any of these areas, these are the nonprofits that you can reach out to learn more about energy efficiency, and they can really guide you through the process of making updates to your home. Energy Smart Colorado is really geared towards existing homes. And then this page are the 4 nonprofits that are sponsoring the webinar today. These are rebates available from those 4 nonprofits. You can see that CORE does have some new construction quarterly grants. So if you are doing new construction and you're thinking about electrification and you're in that area that CORE services, you can reach out to them about incentives for new construction. The rest of these nonprofits incentivize very specifically upgrades for existing homes and buildings. Just reminders that there are heat pump tax credits out there. The federal tax credit is just for existing homes. However, that Colorado income tax credit, you can get that whether it's new construction or an existing home. So don't forget about that and make sure you get your tax credit if you're doing a heat pump. And I would like to introduce David Petroy today. He's the owner of NTS Energy, Home Energy Solutions Consulting. He also just recently consulted with Excel Energy about education for customers' personalized energy use and EVs. He was a sustainability manager at Golden Aluminum, working on facility-wide energy monitoring systems. He was the founder and president of Blue Valley Energy, and he was the lead sales for RMS Electric. He got an MS in geophysics and a BS in zoology. I don't know how all of that led him to know everything about heat pumps, but he is our local, semi-local, but our Colorado region expert heat pump guy, and we're glad to have him here today to present our webinar. Thanks, Dave. I'm going to let you take it away.
Thanks,
I will
Nikki.
stop sharing for you.
All right. Let me get my sharing right here. So maybe we can turn on everybody's mics. I would like to hear what, since we only have a handful of folks, it'd be nice to hear what everybody wants to get out of the webinar. That would be really helpful, because I want to make sure everybody does get everything out of the webinar.
Everybody is allowed to talk. You are on mute automatically, so go ahead and unmute yourself if you have a question in the beginning before Dave gets started.
Anybody have any Anything they want to say about what they're hoping to get out of today, or
Yeah, hey David, it's Mary. How are you?
good? How are you, Mary?
I'm good. I'm good. Hey, we're kind of struggling with the carbon emissions between gas. Like if we try to figure out like a new home that's going to be all electric, what their carbon emissions are going to be versus if they would have put in gas appliances. Because, if we take Holy Cross's grid today, it's like 50% renewable.
Right.
We're finding that gas is actually lower carbon emissions, and I just have we're having a hard time with that, if that is actually true or not.
Um, I don't have I don't have details on this talk for that. Neil and I have done a lot of work on that, so we can dig into that.
Okay.
I think what I would characterize it as, um, with the most efficient heat pumps and around 50% um, renewable grid, um, you're pretty much close on par now. Gas might be a little less carbon, but if you think about the 15-year life cycle of this equipment, 15 to 20 years, um, and the grid becoming, you know, 60, 75, 80, 90% green or renewable, then, then the heat pumps clearly are lower. So over the life cycle, it's a better deal. So the nuances are in the details, but we're kind of at a balance point right now.
Okay.
Um,
All right. So we're not
yeah.
crazy. Okay. That's great. Thanks.
No, you're not. No, not crazy. And like I said, Neil and I we got some numbers and stuff actually. And um, yeah, we've worked. I got a spreadsheet. Nikki, you remember that one? I've got some stuff. If you want me, I can help you work on that stuff. Anybody else? Well, let me just start. Let me just go into it. I've got a lot to go through. So what I'll do is skip some. Um, I don't need to go through. Everybody's going to get the deck. Everybody's going to get the recording. So that way. So a heat pump, I think most of you, well, I don't know if you all know or not. Basically think reversible air conditioner. And literally that's the only difference inside is a reversing valve, and the computer board can go both. The computer board can talk, communicate a little more. The one thing people get confused about is temperature versus heat. Even when it's cold outside, there's lots of heat in the air. Think of it as a heat concentrator. And the outdoor units look like air conditioners. And the amazing thing is you've got refrigerant, which basically loves to absorb heat and give up heat. And so outside, what it does is it comes out of the house really cold winter, and cool liquid absorbs heat, changes into a warmer gas, gets compressed, gets some energy. This is what uses the energy. The more efficient we make this, the less energy the whole heat pump system uses. Comes inside, it's around anywhere 105, 110 degrees. Air goes by it, heats your house. This is a good time to point out that it comes out of that about your body temperature, so it doesn't feel warm, but realize we only have to heat the room to 70, 72 degrees, so it's plenty of heat. So heat pumps have been around for ages, but cold climate heat pumps have not. They were in Europe and Japan earlier than us, but around the turn of the century, there was some oil price increases in New England, and just a lot of people thinking, why aren't we using them more in cold climates? There's no reason physics not to. So there's a lot of work on defrosting, getting them better. A lot of field trials, and then the last decade, 10, 15 years, they've been installed all over in cold climates. Our uniqueness, though, and the uniqueness of the Northern Rocky Mountain states is we have cold climate with altitude, which you have to think about. And there's a lot of things the engineers have worked on, but mainly those compressors I talked about, how to defrost, get rid of defrost buildup, and the matching of the computer boards. Advanced computer technologies really helped in efficiency. So the gains are a couple fold. One is this is outdoor temperature. This green, and then on the left axis is amount of heating required, million BTUs. And this is a typical house, and so it gets colder, it requires more. It's a good time to point out tons. Hello? It's a good time to point out tons. Basically, tons are on the left side. 12,000 BTUs is a ton. So heat pumps used to be in the South, and for many years, just ordinary heat pumps. They would be able to heat the house down to about 30 if need be. And then they are way short on amount of heat. So over the past decade, with the evolution of cold climate heat pumps, now heat pumps hold that's the orange line, they hold their capacity. And basically the heating, they can do all the heating that's required. There's sometimes a little wedge of heating when it's really cold. That's why we usually pair them with a little backup, either all electrical source or furnaces. And next slide. The second thing that was improved was efficiency. This is the last decade, from about 2012, 2022 is similar to what is here. HSPF is heating season performance factor, that's efficiency. And 14 is double of 7. So we start around at 8 and we're up to 13 at the highest. Most units, cold climates are in around 10.5 to 11. High efficiencies are 9 to 10. So you've gained 20 to 30% more efficiency, which is directly lower cost. I want to note that over several years, they've been working on a more accurate way to characterize systems. And they've come up with this HSPF2 and SEER2. If you look on manufacturers' websites, they're listing them as these. If you take SEER and subtract 1, that's about SEER2. HSPF minus 1.5 is about HSPF2. This is pretty close on all cases. This is a little more flexible, but it gets you close enough. So next slide. So we've got 4 improvements: efficiency, higher capacities, defrosting, and the capability to go below 0. So let's talk about the different systems and applying to your home. We've got a heat pump system with a furnace on the right. And basically the heat pump does all the work throughout the year. It's just using the fan and the coil in the top of the furnace. It's just going to save the burner and the furnace part for a very small part of the time. Less than 20% of the heating loads, typically less than 10%. On the other side, you have a fan air handler unit, which looks similar size and shape as a furnace. I mean, the way to think about the only difference is, rather than the burner part below, you've got electrical strip heat to help you out. But one of the newer things, obviously new last 10 years or so, 10, 15 years, multi-zone mini split, which are ductless. And these are really starting, I think, to make their way into new construction more. Up to now, they've been mostly retrofit. You've got 1 outdoor unit. You can go typically up to 4 indoor units. 2 to 3 is pretty typical. Each of these zones independent. The nice thing is these are small runs. Outside of your house, they look like basically inside of a gutter. So it's about the dimensions of a gutter. Inside, the refrigerant lines have insulation, and so they don't require much there. There's multiple indoor unit options. Started out with just a wall unit, but now you've got a variant here in the ceiling with along parallel with the joist. So you can basically think of moving this up flush into the ceiling. You've got another flush centralized unit, a ceiling cassette. This evolved. This came out of applications in the commercial world. These are nice low wall units. Then you've got something very flexible. It's a slim little duct that's very good. You don't need much ducting at all. It's good for like 2 bedrooms that are adjacent. And then Mitsubishi has the most flexible system where you can actually put in kind of a full-size air handler, so you can have some of your house ducted and some not. So what are your strategies for a new home? So the air source heat pump heating and cooling, you can have traditional ducted. You can have mini split multiple zones with no ducts. You can have a combo ducted and mini split. I know in the high country you want radiant in-floor heating. You can combine that with mini split multi-zones, where you can use your boiler as your radiant source, and you can use the heat pumps for heating and cooling in other parts of the house, or I'll talk a little bit more how other ways you can use it together. This isn't the point of this talk. We'll have one in the future, but I wanted to mention, because this is getting a lot of press, a lot of people buzz about it, ground source heat pumps. There's something to consider if you have a house with a pretty big heating load. If you're really focused on radiant in-floor, if you really want to go all electric and, you know, keep your pollution level low, they do have the highest first costs, lower heating and cooling costs. A couple things. There's the supply chain isn't just as large and robust. There's a few vertical field loop drillers and a few contractors. And there's a lot of cost variability. People always get all different kind of numbers, mainly because it costs a lot to drive drill rigs to different parts of the state. And the geology is very highly variable, so it can be hard to drill or easy. Air to water heat pumps is a bigger product around the world, but it's still very niche in Colorado. If you want radiant in-floor heating as a high priority in combination, you want it all electric. So those are super priorities. You have a smaller heating load. It's cost 2 to 3 times a boiler, but it will satisfy these. Or if you have a very big heating load, you can combine this with boiler systems. The supply chain's even more limited. There's a couple designers that do these type of systems and a few installers. So what you want to think about is what your priorities are. I've talked about radiant. It used to be just, I want radiant on all the floors, no doubt about it, perfect comfort. I think it's a lot less necessary than in the past, because super well insulated homes, much better windows. The walls don't feel cold. The windows don't feel cold. So I think it's more to think harder about, where do I want the radiant? You know, just in the main living areas, the first floor, in my master bedroom. You don't need it everywhere now. Where's cooling more important? I can use my mini splits there. So that's one. The other is, what's the layout? You want to look at each floor, and I'll give an example later on. Is it open concept or traditional? Do we have room for ducts either below or above each floor? Do I want to have drops and chases for ducts? Do I have an attic available? What's the situation in my basement? Is it going to be finished or unfinished? Am I going to use the basement a lot? What kind of HVAC do I want there? And then the last thing is gas or propane. Do I want to have that available for other reasons? Do I want it for heating and cooling? It's not necessary any longer for heating. Boy, I'm getting bad on my mouse here. So for whole house, let's just walk. We're going to walk through each of these, make a few comments, give you some food for thought. Traditional ducting used to be, I'll put a furnace in, I'll put an air conditioner in, I have a duct, I've got one thermostat in the middle of the house, I'm done. I have to say, you really don't want to do that. If you've got a one-level home, you really want to think about for 2 things: much better comfort and energy efficiency. A couple of thermostats. Is your house laid out north-south, east-west? And it's very easy, if things are in the basement, to just split the duct system. Zoning controls are not that costly. It's a much better system. And you obviously want to integrate fresh air. I have something about that in a couple slides. If you got a multi-level home, it used to be that everyone would be really reluctant to buy, oh, I don't want to buy 2 outdoor units, 2 furnaces. But really, and you think about the reduced ducting, the better efficiency, you do want to think about putting one unit dedicated for, say, the second floor, one unit for the first floor. It doesn't mean that that's the only option, but if you're going to go with one unit, you can go with zoning. So you want to think about that. And in the basement, really, you can select zones for comfort. Mini splits. So mini splits are a great strategy if you've got like homes with very small 1 or 2 bedroom homes, homes with no spacing with ducting, little condos, townhouse, indoor townhouses, etc. It's a very good way to go, and you can get a nice system. I mentioned about 2 to 3 heads per unit. The more indoor units that you put on an outdoor unit, you have there's a little bit of constraints on the kinds of sizes of the rooms and designing, so you have to be cognizant of that. Small rooms with great insulated new homes, find out that if there is a bathroom or other rooms, it's going to cost you $40 a year to heat it. It doesn't really need cooling. You don't want to put expensive wall units in there. You just put a little bit of heating in there. Talked about the slim ducted, which you can use. It's very nice. You can put bedrooms as a nice combo on first floor, like office and adjoining rooms, etc. And you want to think about careful indoor placement for good airflow. Exterior walls are easy, but not always the best. Gosh. All right. So I want to talk about the mini splits here for a second. I want to show an example of a house where they were almost required, but it's going to be a really good system. This was a SIP house, no basement, no attic, open, generally open, some little rooms. Didn't want to do ducting. Really not practical. So this took several iterations, but we ended up with 3 systems. And you can see there's many rooms. This is this is the first floor. This is the second floor. We ended up with this orange system where we've got a little unit going to the bedroom, the family room, small unit in the garage, just to temper it. You want to be careful about units in the garage. You can't expect them to heat it to 70 degrees. So we had and then in the living room below. So everything kind of on one side. I've got short line sets. I've got a nice placement of the unit. On the blue, I've got this bedroom here. I'm able to run over here and hit my flex room. We figured out a way, basically along the store, he's going to put like a little along here, a tiny little drop. It's only got to be like 4x4 framed in, or 6x6. And then he can run all the way over here, hit his master and dining. These little rooms here are going to have a little bit of electric heating. The other thing here, I'm not going to go into the details, but we spent a lot of time on heat, fresh air, and figuring that out. That could be a whole nother talk. And there was a little outbuilding, sort of a workshop, 2-story. And in the end, it was decided we just put a second system, run it along here and out. So this is a really good example of a new home where mini splits did the job. Now the system with Mitsubishi or combining them is also something you want to think about. So if I have this house here, and if it had a basement, then I could say, well, I'm going to do a heat pump down here. I'm going to have 2 zones. This is going to be one zone. This will be another zone. Put my thermostat in the home office. Very simple in the basement. I have no basement. I don't really have room for ducts. All right, I'm going to maybe put 2 mini split systems here. One on this side of the house, one over here. I've got a unit on this wall, over here in the kitchen, here and here. And then upstairs, I could go this unit. I could put a little slim ducted in here and get these 2 rooms. I can go over here with this one. I can get the owner's retreat and run my line and figure out a way to go around and get this. So a couple of variations, or no basement, attic. I can go up here and do a 2-zone duct system and my mini splits below. Now, combining radiant and mini splits, there's going to be rooms, let's say there's rooms you want radiant and you want cooling. So you can use both systems and optimize it, because for the spring, the summer, and the fall, the mini splits can be the way to go, because heat pumps are far more efficient in the spring and the fall than the dead of winter. That they might be running at a COP, and I'll talk about that in a minute. I've mentioned a bit 4, which means 4 units of heat for one of energy in. And then I can turn the radiant system on from, a little gas boiler. I'm just using it in the winter. But otherwise, I only have to put radiant where I really want it. Maybe I put mini splits on the warm side of the house and radiant in the north. Little rooms, you don't want to do mini splits, use the radiant. And I'm going to need in the basement, hardly any heating at all. I do require fresh air. So one of the concerns for new home construction and all the very tight requirements is getting fresh air. Old homes, to give you an idea, they would have 1 air change per hour just through leakiness. Now we want to have it 0.35 or lower. So this is essential. And sure, you can open the windows, but it's when it's super cold, super hot, or smoky for 2 weeks. It's called a heat recovery ventilation system. Rather than bring in cold air straight in or warm air straight in when it's the summer, it goes through a box. It exchanges the heat with air that you send out. So air that would come in at 10 degrees might come in at 40 or 50 degrees. And you can integrate this with an air system very well. If you don't have an air system, you can set up these boxes and do little ones, and maybe eat one for each floor. Well, there's now some through the wall ones, which are really clever. We're doing for that house I showed a couple slides ago. So let's talk about economics for the next 2 or 3 slides. COP, I mentioned, coefficient of performance, says 1 unit of energy in, how many units of heat out. Natural gas furnace, 95% is 0.95. Electric heat's 1. Heat pumps over the average over a year is 3. Spring and fall, when it's milder, might be up over 4. Winter, when it's really cold, 1.5 to 2. Average is over a year that. So compared to propane and electric, it really saves a ton, 60 to 70%, because this is 3 to 1 out of the blocks, and propane is pretty expensive. With natural gas, it's interesting. In the past, 10 years ago, natural gas really low would have always been natural gas a lot less expensive. Now I'd say it's pretty much on par. It really depends on any given winter, what's the price of natural gas? What's the price of our electric? So plus or minus a few percent here and there, but basically you can say they're pretty much on par. Now, the advantage of the heat pump, if you combine it with the furnace, is you've got 2 kinds of fuel. You can sort of flex a little. But I think one thing and I've talked about the heat pumps. So basically from like mid-March all the way to November, heat pumps are unbelievably efficient. Like in the fall and the spring, you couldn't have a gas price low enough that would compete. In the winter, gas sometimes is less expensive to run. But the interesting thing is, I think people are surprised about how much our energy costs and how much we use during most of the year and when it's very cold. This is minus 20 to 70 outdoor temperature. This is the percentage of annual heating use. The big thing is here above about 15 degrees in the high country, 80% of your energy use, 18% when it's really cold. And these temperatures, this is easy for heat pumps to operate. This is a little table here. This gives you an idea of heating costs. This is some of the system costs. So I'm not going to go through all this detail. This is propane and electric. Basically, the payback with all the rebates. And this is these are sort of the rebates for retros. Next slide, I got some stuff on the new homes. But really, very quick. You know, it'd be crazy to not put in heat pumps. Even with natural gas, like I said, the operating costs are pretty much plus or minus. The first costs, gas and AC versus heat pumps, are basically on par, a little bit lower. I tried to, I want to talk a little bit about, you'll hear out there now, right now with the heating and cooling industry, things are expensive kind of no matter what you do, just the way it is right now. But there's a lot of apples to orange comparisons going on, which we really need to have, you as homeowners have to understand and make sure you're getting apples to apples. So let me just, I put in here like 2 product levels. Let's call them 1 and 2 to make it easy. System efficiency. So these are kind of the Sears, and this is 1 or 2 speed air conditioners, 1 or 2 speed heat pumps. So you put a system in. It's a furnace and an air conditioner, and you put in or you can put in furnace or an air handler and a heat pump. So furnace or air handler with electrical, either one. Most of the stuff's going to be about the same price. Really, the difference is in the heat pump and AC. So the heat pump's still a little more. The reason is it's bigger than the AC in size, like tonnage, bigger, and you need stands, you need some other stuff, a bit more. But relative cost difference after rebates and tax credits, the heat pump is less. In fact, depending on where you are, like the Holy Cross rebates are extremely generous. This number would be even more slanted toward heat pump side. Then you've got level 2. And this is variable speed air conditioners and cold climate heat pumps. You know, this is the real modern technology. Put in nicer furnaces, you put these in, and it's more expensive. Heat pumps are more. So then it comes out to be more or less on par. Now, in fact, I probably should open this window more because honestly, if you, it's hard to keep surveying all of the rebates and everything, but up in the high country with Holy Cross and the other rebates, the heat pump would be a couple thousand less. But here's what happens. People go out and get quotes and they talk to contractors. These systems are a lot more expensive than these systems. Thousands of dollars, $5K plus. But what will happen is they'll say, well, heat pump's a lot more expensive because what they compare is this system to this system. Because what happens is really it's hard to justify, honestly, it's really hard to justify a super high-end AC and up in the high country. You just don't use the AC, even the front range. But it's not fair to say, I'm going to compare the lowest cost this way to this. I mean, if I flip them around, the heat pumps would be a lot more expensive. So really, if you're in situations, it's always like, hey, give me the comparable one. Then give me the high end compare. And you'll find out heat pumps are very favorable. Let's talk about quickly here, using a lot of time, but got to go through this important section here is, you know, in the past, heat pumps just haven't been set up right. They haven't been sized right. So there's been misconceptions. It's been kind of growing pains. I think we're getting through most of them. So how do you size? You need to get called a manual J. That's this green line. It says, how much heat do I need to heat my house? And then it goes up. And then a designer, this is an older slide and updated, will say, okay, I've got a heat pump. My outdoor temperature, I want my heat pump to go all the way to 0. How close can I get to matching this green line? This is a really high-end heat pump. It comes all the way across here. This little blue box supplemental, I want to minimize. Let's dig into this a little more. This is the annual heating hours. This is the load. 30 to 62, mild, no brainer, heat pump all the way. Hours are 50%. Heating load's half of the annual heating load. 5 to 30, still great heat pump range. The hours are still up there, almost half. So now we get to less than 5. Believe me, when we talk about all this design stuff, it's all focused on this part of the curve. maybe less than 5, less than 10. It's all focused on how do we do that part of it. This part's done, simple. Let's talk about ducted cold climate heat pumps. So I'm going to say, and this is a compliment. We have the Mitsubishi Bison color. Mitsubishi cold climate ductless systems have been the best in Colorado. Tons of people have them, but them and the other high-end mini split ductless, they go down to -13 F outdoor. That's what they're spec to. They operate. So we've got this bias in our head. All these heat pumps should work super well, way cold. The bottom line is most of the ducted specify operation down to -5, -7. Not quite up there with them. And you want to think about everyone. You don't want to necessarily figure out design and say, I'm going to run my heat pump at the design spec hard all the time. So you want to back it off. So the way I think about it is you design, size the ducted system. It can carry the load down to about 5 degrees, cold climate heat pump. Now, if you'll remember, in many slides ago, I said the challenge above New England and Minnesota, we have altitude, and heat pumps capacity is diminished at altitude on the air systems, because, and actually furnaces and air conditioners, all of them. So you've got this reduction in the capacity you have to take into account. And there's manufacturers that can at these sizes, but above about 4 tons, you really don't have a lot of heat pump choices. So up to about 3 to 3.5 tons at altitude. Denver more, 4 tons. First of all, quality shell and insulation, smaller systems. Design temperature. So when we do manual J, it says, you pick Eagle -6, you should die. Pick Denver -1. Gets colder there. I'm also looking at my heat pumps. So I want to look at 5, -5, and -15. When I design a system, how well is it going to work at each of these temperatures? So ducted systems, it should be able to heat the whole house to -5 or 10. You know, if you have no natural gas, you want all electric or dual fuel with propane, it's got to be a cold climate heat pump, and it's got to be able to really heat almost all down to 5, because these expensive auxiliary systems. Got natural gas, you got a little more flexibility. You can go to a level 1 heat pump with a furnace. You still want to size it down to 15 or 20. So doing about 80% of the load heat pump. Or you can go dual fuel with a cold climate and size it even more aggressively and get, and you got to account for that. 4 to 6 tons, it gets a little tough. You're really going to have to go with a couple of heat pump systems. Or you can kind of cheat a little bit and go, like I said, you can use the furnace and the biggest heat pump system, you're just going to be using a little more natural gas than before, but still mostly heat pump. I only got a couple more slides. This is my fancy new slide. I'm hoping to make something simple, complicated, less simple, but it looks complicated. But let me try to go through it, because this addresses a big question. You will out there, there's some folks say you don't need backup, other folks need backup, etc. Let me try to explain why sometimes 2 apparent experts come out on different sides of that fence. This is the amount of heating you need on the left side. The right side is hours per year. This is outdoor temperature. So let's start with the green or the red. And I maybe should flip it around because I used green before. This solid red line is what I did with my model. This is my manual J, and it says this house is going to require this much heating. Well, manual J is rather conservative. And in fact, this is kind of a lower bounds that houses typically will fall in this. But I don't really know until the house is built and running exactly where it's going to fall in this range. It's probably not going to fall up here. Probably, you know, it's generally more in the middle. So that's one. Number 2 is the heat pump. And this is a heat pump factory specs. It says at these temperatures, this is how much it's going to put out. But this is kind of a field performance lower range. And in the appendix, I have a lot of this slide that talks about specific things. But typically, the heat pumps aren't going to perform to perfection. And so they're going to perform a little bit less. So what happens here, and then let me describe the third. This is the number of hours. So also, temperature doesn't stay the same every year. My model says this is exactly how many hours per year. Black line says this is a cold winter. Dash line, this is a warm winter. That's how many hours at each temperature. So, and the axis is basically 10-hour blocks. So you can think of that as a 10-hour night. So this would be like 8 nights. Basically, somewhere around 8 nights a year, I'm going to be here. Now, so I'm a designer. I don't know where in here exactly this is going to fall. I don't know where exactly this is going to fall. But I can say if my heat pump performs about in the middle, and my house performs about in the middle, I've got this triangle I've got to make up with some kind of backup heat. The other thing is, and I'll label it when I send this out, this blue arrow is where I talked about ducted systems. I said -5 is kind of their outside of most of them. So I designed a 0, and I can't really necessarily count on them doing much below that. -13 are these premium Mitsubishi systems. So I got -10. So now look at how many hours. Well, there's some hours in here. This is 8 nights, 7 nights, 6 nights. So if I'm a contractor and designer, if I could talk to you as a homeowner and say, hey, will you sign this piece of paper? I think you're going to be cold. I don't know how cold, maybe 60 or 50 on 8 or 10 nights a year, or 20 nights a year. I don't really know. Are you going to be okay and not call me up? So this is why most designers are conservative. Now, I will say with heat pump, with the mini splits, depending on how you size it and how tight and how confident are, I'll talk on another slide, you can decide to go without backup. So really, we're looking at this backup. I'll accelerate a little bit. This is the auxiliary heating. If it's a furnace, it don't matter. Furnaces, you can size them up. They're not that expensive. You put it in here. If it's electrical, you want to be careful. You don't want to overdo it. And there's a size. So that's what, I'm not going to read through this. You can read through it. This is what things you can do to make sure you don't use the electric strip a lot. How do you know you're getting a good system? I'm not going to read through this, but there's a lot of talk, a lot of things in here about, okay, this is what a good system is. Let's talk quickly about mini splits. Basically, all the mini splits are, well, you got to get a cold climate, low temperature system. There's not, here's the best ones out there. You know, it's going to operate down to -13. If you want to really try to get to no backup or minimize backup, you want to see if you can size it to -10. It might be overdoing it a little. You got to make sure it's altitude, and then maybe in the front range, you know, case by case basis, you can get away with no backup. But for the high country, I'm recommending, you know, you still want to have some kind of a backup. I'll skip over this, but this is mini splits. The indoor units have to be sized also. You know, duct systems are sized to do well for each room. Similar thing here. So you can read through that. And this is outdoor tips, running long. So basically, you don't want to end up with snowy mess. You want to have it covered. You want to have it elevated. You want to have a good side of the house. You want to think about noise. You want to have good ducts. Indoor mini splits, you want to make sure you run things well. Contractors, who's your builder like? Who do your friends like? Who do the manufacturers think are good? Have they been doing heat pumps? If they're kind of spending their time talking you out of heat pumps, get somebody else. And then this is local support, which is good, and I think I'll wrap up there. Because I've chatting for a long time.
Thanks, Dave. I don't see any questions in the Q&A or the chat. Would anybody like me to allow them to talk? Do you have questions, or do you have something you want a scenario you'd like to run by Dave? I'm gonna go ahead and allow you to talk just in case you can think of something. You'll need to unmute yourself though. And Dave, can you point out that you have an appendix in these slides as well that they'll get when they get the...
Yeah, there's all kind of, yep.
Cool.
And there's more, I'm gonna add some more at the end. But yeah, there's lots in the appendix. And, you know, the rebates, the savings, it's phenomenal. So there's really no use considering any kind of air conditioning system, etc. If you want radiant, it's good combo systems.
Well, it looks like there's no questions. We will email out a recording of the webinar as well as all the slides, and some general information sheets and a website link and things like that. Just a real simple email for you. So that'll come out in the next, hopefully, few days.
Yep.
We'll also post it to YouTube. Any last minute questions before we get off the webinar and end the call? All right. Well, thank you. Thanks for attending. And thank you so much, Dave. We'll see everybody on August 16th for another webinar all about new construction, really geared though towards contractors and builders.
Developers, yeah.
Developers, yeah.
Yep.
So register and tell your friends to register for that webinar. Thanks, everybody. Have a great evening.
Bye.